Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. The sum of first 23 consecutive terms of a sequence of positive integers in arithmetic progression with a positive common difference is 1564. What is the maximum possible value of the 15th term of the sequence? So we are given a sequence in arithmetic progression, and this is a sequence with positive integers, and the common difference is also positive. So let's call the terms T1, T2, so on, and we have the sum till T23 from T1 through T23 given as 1564. So one of the things that we have to often take advantage of, especially when we are given a sum of odd number of consecutive terms for arithmetic progression, is simply the symmetry of it. And what I mean by that is, if you consider the middle term, so we have an odd number of terms, in this case we have 23. So if we find the middle term will be, in this case, the 12th term. So in general, if there are n consecutive terms and n is odd, you basically look for the n plus 1 divided by 2, the term with that number. So in this case, n is 23, so n plus 1 will be 24, and 24 divided by 2 will be 12. So we're looking for the 12th term, and that's the central term in this particular sequence of 23 terms. And this will be symmetric about this central term. And what I mean by that is, if you look on either sides of this term, meaning if you look at the 11th term and the 13th term, for example, you have the 11th term, you can write it as T12 minus D. The 13th term, you can write as T12 plus D. And you can carry on like that till you arrive at the first term on one end, and then on the last term, which is the 23rd term, on the other end. And now it's easy to see the symmetry. So when you sum these terms up, the terms involving D, which is the common difference here, so D is the common difference. So the terms involving D, they get cancelled out because of the symmetry. And what you're left with is simply 23 times the central term, T12, right? And that's given as 1564. And from this, it's pretty simple to calculate what the 12th term would be, right? So T12 will be 1564 divided by 23, and that comes to 68. So if T12 is 68, we know that in an arithmetic progression, the nth term can be expressed in the terms of the first term and the common difference D as simply Tn is equal to T1 plus n minus 1 within parentheses and multiplied by D. So knowing this, we can simply write T12 as T1 plus 11D, and that's equal to 68, from which we have T1 is equal to 68 minus 11D. And this one I put in red because this is a relationship or an equation to which I'm going to refer back. Now let's come to the 15th term, T15. So T15, going by the same relationship, will be T15 equal to T1 plus 15 minus 1 multiplied by D, which comes to T1 plus 14D. And now if we substitute what T1 was from that equation which I wrote in red, T1 will be 68 minus 11D. So this becomes 68 plus 3D. So what would be the maximum possible value of T15, which is what we are asked to find out? Well, that really depends. From this relationship that T15 is equal to 68 plus 3D, the maximum value of T15 really depends on the maximum possible value that D can take. And we know that D has to be a positive number, right? And it has to be a positive integer because the sequence of integers, so the common difference, by definition has to be also an integer, and it is a positive integer, right? So the question really comes down to here is, what's the maximum possible value that D can have? And for that, we again go back to the expression which I have written down in red, which is T1 is equal to 68 minus 11D. Now, since the terms of the arithmetic progression are all positive, T1 has to be greater than 0, which means that 68 minus 11D will have to be greater than 0. And from this, we have 68 by 11 greater than D, or the other way of writing this is D has to be less than 68 by 11. And since we know that D has to be an integer, the maximum possible value of D will be 6. So if the maximum possible value of D is 6, then the maximum value of T15 is simply 68 plus 3 times 6, which comes to 86. So the correct choice in this case will be option C, 86.